In this problem, we're told to model with a linear equation. We know that a linear equation is going to have the format of y equals mx plus b. We know that m represents the slope. We know that b represents the starting point of the y-intercept. And then we're to solve the question. So let's take a look at our diagram. I see that the building is 50 feet tall. So right here is kind of the point on that, 50 feet. I see that the wall here is 35 feet tall. So again, marking that point, 35 feet. I see down here at the bottom edge that these 2 points are 20 feet apart. So that's going to be really important. And then as this continues, the line that I'm working with is the sight line. So this is my line, this diagonal line. And I see that the distance here at the beginning is 6 feet, so that is my starting height. Oftentimes I superimpose a coordinate plane. So if I would superimpose a coordinate plane, so here is y-axis, and the ground here is an x-axis. And this helps me get the idea of ordered pairs from that coordinate plane. And so one thing that I immediately see is right here, this ordered pair of over 0 up 6, because that is right on the axis. And then it's kind of a little awkward because this looks like it would be going in the negative direction on the coordinate plane, and yet the distances are positive because we always measure distance as positives rather than giving direction to distances. And the other awkward thing is that I do not know how far this wall is from the person. That's what they asked me to figure out. So I can't really give an ordered pair at the wall because I don't know how far it is from the axis. But it can still really help me to see this as there is a coordinate plane sort of in the background here. And so because we were to write a linear model, we always want to start with slope. We know that slope is change in y over change in x, and we know that we find those changes by doing subtraction. We also know that y represents the vertical. And so if I'm looking for vertical change, I have from the starting person, who was 6 feet tall, to the wall as a vertical change, and from the wall to the building as a vertical change. So one that I want to use is from the wall to the building. And the reason why I want to use that is because I'm told that the wall and the building are 20 feet apart. So I also have a corresponding horizontal distance to go with them. Whereas I don't know how far apart the person is from the wall. So I cannot use that in figuring this out. So I'm going to use 50 as my y2 minus 35. And I truly do not know how far the wall or the building are from start. So I can't really use ordered pairs, but I do know that the change, the distance between them is 20 because I'm told this. So this is the horizontal change, just all calculated for me because it's telling me that they are 20 feet apart, so 20. So I do the math and I have 15 over 20. And if I divide that out, because I'd rather work with the decimal, 0.75. So now I'm going to see if I can write my equation, and I definitely can because I know y equals the slope 0.75 x, and then the plus b is how high up I start because it's a y-intercept, and we actually were able to figure that out, that we started at 6. Now sometimes this can be a struggle to people because they're thinking like our slope should have been negative because it looks like the line is downhill. And they're not wrong. The slope could be negative because the line is downhill. And yet because we always measure distances in positives and think of the negative only as a directional piece, having the positive slope makes a lot of sense too. So then the next thing that I want to do is try to answer the question. And the question starts here at the end of the text on the screen. It says, how far north of the wall must you stand in order to view the top of the building? And so how far is the wall and the man? How much are they separated by? And I see that here with this question mark on the image. Well, there's a lot to think about. So I have my formula, and I have a y value of 35 right here for the wall. And so I'm going to put in that y value. How far over would it be for me to get a y value of 35? So 35, the wall, is 0.75x plus 6. That's the equation. And the x here will tell me a horizontal distance, which is what I want to figure out. So I go ahead and subtract x from both sides. So 29 equals 0.75x, and divide by 0.75. X is equal to 38.67. So how far are these away? Well, 38.67. And that would be in feet, because the problem is in feet. So you may be wondering, why did I pick the 35 and not the 50? And the reason why I picked the 35 is because it asked me about the wall, not about the building. Why did I put the 35 in for the letter y? And that's because the 35 is a vertical distance, which our y-axis is the vertical axis. And so that's why I put that in for a y value and then solved out.